Alright guys, we're going to be solving another question from the second chapter of the Meriam textbook, Engineering Mechanics. And this one, for the conditions that theta is 40 degrees and our tension in the cable is 150 newtons, we know that the radius of R is 200 millimeters, and we need to determine the moment of the tension T applied by cable AB to point A about point O. And as always, we're going to consider counterclockwise moment positive and clockwise moment negative. So the force that we are dealing with is the tension in the cable, which would be T on every single point of this cable. So that's our force T. And what we need to do in here is to find the moment about point O. And if we can just resolve this force into N and T components that we can see in the figure, this will be Tn, and the one perpendicular to that would be Tt. If we can resolve this force into these two components, we can see that only the Tt or the T component of the tension is going to make moment about point O, and it will be actually perpendicular to AO, but for that, we need to figure out this angle right here. And how do we do that? If we draw a line parallel to our x-axis, which we can see in here, we know this angle here is what we have on top, or the angle theta, which we know is 40 degrees. And as long as we can find the little angle underneath this one, we should be good to go to find our TT. And finding the moment is pretty easy, so our moment would be counterclockwise as always. And if you look at the T component, we'll see that the moment it's going to be counterclockwise, so we'll be positive. And we can see that TT would be T sine of that angle, which we can call it for now 40 plus that little red part. Let's just call it alpha. And that would be our force. And AO would be our distance, which is pretty easy to find because AO is basically the radius that we have as R, because it's going to make that circle that we can see. So AO is basically R. So all we need to do in here is just to find that angle alpha. And for finding the angle alpha, what we're going to look at is we have this right triangle that I'm highlighting in green, and finding the sides of this right triangle is not that hard. So if we want to find this side, we basically have R minus, we have this part minus this part. So for finding alpha, if we want to find tangent of alpha, we have the opposite, which is what I just showed, will be R minus this part, which would be R sine of theta. So R minus R sine of theta is going to give us that side. And for the other side, which is the distance from A to here, or this distance, we know this part is R, and this part, we can look at the right triangle that I'm highlighting in yellow, like this one. That's going to be R cosine of 40. So our theta is basically 40. I'm just going to put 40 in here too. So R plus R cosine of 40. So now we can find alpha, which would be tangent inverse of, we can factor R in the numerator and denominator. So we're going to have 1 minus sine of 40 degrees over 1 plus cosine of 40 degrees. 1 minus sine of 40 divided by 1 plus cosine of 40. So our angle would be 11.43 degrees. And that's pretty much it. For us, for finding the moment, we basically have our T, which is 150 Newton, times sine of 40 plus 11, 43, which is going to be 51.43 times R. Our R is in millimeters, so we're going to divide it by 1,000 in order to get it in meter. And that's going to give us the final answer. So 150 times sine of 51.43 times 0.2, and that would be 23.46 Newton meter. And as I mentioned, because we have a positive moment, it will be counterclockwise. So yeah, that's pretty much everything for this one. Hope everything was clear. Let me know if you guys have any questions, and you guys take care. I'll see you in the next video. Have a good one.